Mute your mics. Mute your mics.
Hapa ni Sharukamba Romba hapa.
Hello, mute your mic.
Hapa sio Mveka Hurukamba.
Yeah, man. Okay, so let's begin. We're not waiting for anyone. This is recorded on YouTube. So unless if you have a question, you can ask. We'll start from the simple ones, then we'll be moving to the tough questions. So what you do, if I put a question on screen, you screenshot it, because I'll remove this and I start solving it on the screen. So what you do, if there's a question like this one on the screen, you screenshot. So before we begin, can you all get me clearly here?
Yes, sir.
Okay, thanks. All right, so I hope you have screenshotted this question. I'm removing it. And so under electricity, we have two types of electricity. We said we have, okay, current and static electricity. So this type of electricity is under what we call the current electricity. So now, what do we do to answer this question? So let me see if it can be clear. Yes. Okay. Now, we have two. So under series connection, I don't know if you can see, but we're answering that question. Under series connection, number one, we said that what you have to understand under this type of connection, if you have got a series connection, these are the rules. Okay. So under this type of connection, the rules are that if you have the resistance here, if you have got 1 ohm and here you've got 3 ohms, and at this point the voltage is 12 volts, and here there is current A. Okay. Then the question is asking you, what you have to understand, the current that is flowing through this conductor is the same. The current through this conductor is the same. So if your current that you're going to find is, let's find the total current here. We're going to use the Ohm's law. First thing, you have to find the total resistance. We said in series, the total resistance is simply found by what? Adding them. So we have 1 ohm here plus 3 ohms here. So meaning the total resistance is going to give us 4 ohms. Okay. Now, this is question 1. Question 2, find the current passing through the cell. You use the Ohm's law. Current or resistance is equal to voltage over current. What was your total resistance? It was 4. What was your total voltage? It was 12. The current you do not know. So what you do at this point, you cross multiply. This will give you 4I is equals to 12. You divide both sides over 4, even this side over 4, meaning your current is going to be what? 3. So your current is going to be 3 amps. So what does this mean? This means that the current passing through at this point is 3 amps. Even the current passing through at this point is 3 amps. The current is the same. The one which is going to differ here is now the voltage. What voltage is passing through? So in series connection, the current is the same, while the voltage differs. So the current is the same, while the voltage differs. So what you're going to do here, you say, for me to find the voltage passing through at one resistor, we say, okay, resistance is equal to voltage over current. What resistance have we been given? We want to find the voltage passing through at 1. We say, okay, resistance is 1 itself, 1 ohm. What is voltage passing through at 1? We don't know. What is the current? The current is the same throughout the cell. So you get the one that you found here, 3, you put 3 here, meaning you cross multiply. Your voltage is equals to 3 times 1, you get 3 volts. Meaning what? How many volts are passing through at 1 ohm resistor? 3 volts. What about this side? How many volts are passing through at 3 ohm resistor? You are going to do this. Okay. You say resistance is equal to voltage and what? Current. What is the resistance? We are finding 3. Then the voltage, we don't know the voltage passing through at this cell. What is the current? The current is the same throughout, which is 3. you cross multiply here, meaning our voltage is equals to 3 times 3, 9 volts. So that when you add the 3 volts that you found here and the 9 volts at this point, 3 plus 9, the total, it should give you this total voltage, which is 12. We've seen that. So this is how you just tackle the question. This is just an example. So now when we want to answer the question that you have been given, okay, in an exam, this simple one, because we're answering a lot of questions, you make sure where you don't understand, you ask. You can unmute yourself, but you allow me first to talk. When I finish, you ask. Don't interrupt. Okay, so this was the question, if I'm not mistaken. So this was the question here. So as you can see, our question is saying what is meant by EMF. Okay, so but the main point that you want to find here is how do you find the total resistance, and the other one is calculate the voltage across the 4 ohm and the 8 ohms resistor. So first thing, the question is asking you to calculate the what? The current through the cell. So how do you find the current? So our question has been given like this. I told you to screenshot. So this was our question. It was signed. Then here we had 4 ohms, and at this point we have 80 ohms. And this is the question. So the first question is saying you have 6 volts here. What does it mean when they say what is meant by EMF of what? Of 6 volts. What does it mean when the question says what is EMF of 6 volts? What does it mean, EMF of 6 volts? So it just means that the force or the voltage that is needed or that supplies the entire circuit, that's this voltage here. So we're saying that it means that the force that exists between the terminals of the battery to drive the current, or the force which supports the system, that's the voltage here. That's what they mean. The second question was saying calculate the current through the battery. So what current is found through the battery? To find the current, number one, you use the formula of total resistance is equals to total voltage over current. For you to find the total resistance, you must have the to find the total current, you must have the total resistance and the total voltage, which is 6 here, of course. So what you do is make sure you're active with your calculators. You have to find the total resistance. So how do you find the total resistance when they're in series? Someone tell me. Where is my calculator? When they're in series. Yes? Feel free. How do you find resistance when they're in series? How do you find resistance when they're in series? Can you get me? Oh, we add them. Okay. So, good. In series, we have to add them like this. So we're going to say we have this 4 ohms plus 80 ohms. The total here, it is giving you what? 12 ohms, is it? So 12 ohms is the total resistance. It's the one that you're going to put here. 12 ohms is equals to, what's the voltage? 6 volts. What's the current? You do not have. So at this point, you cross multiply. It will be 12I is equals to 6. So you divide over 12, even this side over 12. You say our current is equals to, what do you find? When you have 6 over 12, what's your final answer here? I need a class that is participating. Okay, 6 divided by 12. You have to write your answer in points, not in fraction. This is electricity. You are not going to say half, 1 over 2. No, you just say, okay, 0.5 amps. Okay, that's the current here. Are you getting that? Good. 0.5. So meaning I've gotten your mark here. And that's how you find the current, the first question. Then number 2, the question is saying calculate here the voltage across. So they want individual voltage. What voltage is passing through at 4 and what voltage is passing through at 8? Individual voltages. What voltage is passing through at this point and at this point? And don't forget, once you find that voltage, when you add it, it's supposed to give you the total, which is 6. So what did we say at first when solving that example? We said that we're going to do this. Ohm's law, resistance is equals to voltage over current. What is the resistance? First one, we're going to say RT, 4 ohm resistor. Let's find the voltage at 4 ohm resistor. So what resistance have we been given? At 4 ohm resistor. What's the voltage? It's the one that we want to find, the PD, at this point. Then what is the current? The current is the same throughout the cell. So if the current is the same throughout the cell, meaning it is the same 0.5. So we cross multiply, meaning voltage is equals to 4 times 0.5. What's your final answer? 4 times 0.5, what do you get? 2. 2 volts. Good. You have 2 volts. So meaning what voltage is passing through at this point? 2 volts. Mayonaka? Can you see it? Meaning what voltage is passing through at this point? Okay, we have 2. Want someone? Let me see if I can. Not hearing anyone saying anything. Your mics. Okay. All right, so this is how you find the voltage at 4 ohm resistor. Then how do you find the voltage at 8 ohm resistor? The same formula applies. Resistance is equals to voltage over current. So you're going to say, what is the resistance we want to find for 8? So 8 ohm resistor, what's the voltage? We do not know the voltage at this point. What is the current? In series, the current is the same throughout. In series, the current is the same throughout. So it is 0.5. What do you do at this point? You cross multiply. Meaning voltage is equals to 8 times 0.5. You get what? What's your answer? 8 times 0.5? 8 times 0.5. Your answer is what? Okay. So you get, all right, see comments, you get 4 votes. So meaning your answer here, we're finding votes. Okay. So this is voltage, so it's in volts. So meaning at this point, the volts passing is 4 volts. So when you add them, 4 volts plus 2 volts, your total volts is giving you what? It's giving you 6. This is how you find the first question that I gave you this point, and that's how simple it is. So this is how you work out this question. As we go to another question, good. So another question, I can bring it on screen. Bring it on screen, you screenshot. Okay. Question 2. This one, Bwerawadia. Can you see it? Okay, can you see the question?
Yes.
All right. You can screenshot it.
No.
Or maybe there's someone who wants to attempt. So those that are doing online classes, your normal learning is starting on Monday. And this whole thing we're doing is just for showing you. As days, the way days are moving, you'll be solving. That you'll be able to open your screen to show us on the book how you can solve this question. Now, the first thing that you need to do, understand what the question is asking you. If you can see this question is so funny, whereby you have 2 types of connections at one point or in one circuit. You have the series connection and you have the parallel connection. Do you agree with this?
Yes, sir.
Yes,
we
yes.
do
So,
agree.
so what do you do? Since you agree, now what can you do? Try to agree, you can. Now what do you do up? 1.6. Look at the first question. Who can read the first question? You just read it out. So understand what is asking.
The
What is that
effective
question?
resistance of the current.
Okay. The effective resistance of the current. Have they said only in series, or they've just said the total effective resistance? So we have, okay, so meaning you have to find the total of everything. So this is what you do. I hope you have screenshotted that question. Let's proceed with answer. Let's answer now. Okay. Ndiye kakaoneka sote. Kaboza. Okay. Now, this question, the first question is to find effective. This is in series. I mean, this is in parallel and this is in series. So what you do is this. When you find the one in parallel, the answer that you're going to find, you just add with one in series. That's all. Because this is in what? In parallel. So when you find your total for the parallel, meaning your answer, it is going to be aligned in series. You just add with this. So how do you find the resistance in series? Total resistance is equals to resistance 1 plus resistance 2 over resistance 2 plus resistance over resistance 1 plus resistance 2. So the formula is resistance 1 times resistance 2, then over resistance 1 plus resistance 2. So whatever you're going to find here, you're going to add with the resistance 3, which is this one. Okay, which is this one. So don't worry first for adding. Let's first find the total for this. When you find the total, they're now going to be in straight line, meaning they're now going to be in series. Once you find the total, when you find your total, it means they're now going to be in series. Here, there's already 1.6. Once you find your total, it means it's going to be in series, and you simply add there. So we're going to say R1 is 6. 6 times R2 is what? 4 over 6 plus 4. Okay, so you find it in this format. Don't trust your head. Even if it's 2 plus 2, 6 times 4, you get your answer 24, right? So you have 24 here over 6 plus 4, you have 10. So what's your answer? You go 24 divided by 10, right? You get your answer, what divided 10? 24 divided by 10. You get your answer as 2.4 ohms. So this is the one for the total for the parallel, meaning here you have got 2.4 ohms. So meaning what is the total now? So meaning total is equals to 1.6 plus 2.4, meaning our total resistance is equals to this, which is 4 ohms as the total resistance. Is this question clear? Should we move on?
Yes, sir.
Okay. Okay. So that's it. That's how you find this question. The next question was saying it was saying what is the current through the ammeter? Now after finding the current, after finding the effective resistance, which is 4, the next question is asking you to find the what? Find the current here. The question is saying the current through the ammeter. Current means everything. So what do you do to find the current here through the ammeter? This is where the ammeter is located. The ammeter is at this point. Okay. So I want someone to tell me, before we even find the current, what do we do in this case now that we have two connections, but we found the total for everything is 4. So when we want to find the current, which formula are we going to use? Which formula are you going to use? No more. Don't make things hard. No. Resistance is equals to voltage over what? Current. The total resistance for the entire circuit, you found it was what? You found it at this point. We say it was 4. So you say the total resistance, we found it was 4 ohms, is equals to what is the total voltage? The total voltage is here. It is 6 volts. What is the current? We don't know. That's why we want to find the current for the entire cell. So 4 current is equals to 1 times 6 over 4, even over 4. So meaning the current passing through the point, you go to your calculator, you say, all right, my calcu, 6 divided by 4, you get 1.5. So 1.5 amps is the current, meaning that's your answer for that question. That's your answer for that question. Good. I can see some comments. Can see people solving. That's how you solve this question. And the last one was asking you determine the potential difference across 1.6 ohm resistor. The PD means what? PD means the voltage. And in series, the voltage is different. In parallel, the voltage is the same. So the voltage in series, it is different. In parallel, it is the same. So how do we find the voltage in series connection? Very easy. How do we find the voltage in series connection? Like what the question is asking us here for C, determine the voltage in series connection. So the PD here, it is different. And at this point, the voltage is always the what? The same. So you're going to find it using the normal formula by saying, hope you're writing what we are solving, because you have to have a book. When I tell you screenshot, when it's time to answer, we answer together. That's how you are learning. You are just watching like that. You are watching another phone. You are on TikTok. Now, so let's find the voltage passing through at this point. At this point, the voltage is the same. What voltage is passing here? Resistance is equals to voltage over current. What is the resistance? We want to find the voltage at this point, 1.6. What is the voltage? We don't know the voltage passing through at this point. But what is the current? The current, we know that it is the same in series. The current is the same in series. So the current that we found was 1.5. We get the same one, 1.5. So we cross multiply here, meaning what voltage is passing through at this point? Okay, you get your calculator, 1.5 times 1.6. Your answer is 2.4 volts. Meaning how many volts are here? 2.4 volts. Meaning the rest of the voltage, it will be shared for these and it's going to be the same. Okay, that's how you find it. And this question is done like that. Is it clear? We proceed. We have a lot of questions. Is it clear? Ask Safunsa Anadiapura. Okay. Silence means it's clear. Okay. Silence means it's clear. We go to another question. Another challenging question. These are too simple. That's why behaving like this. Okay, so sending another question now. Wow, this is tough. Okay. Okay. All right, so this is a simple one. I believe you can all see it. Can you see it? Can you see this question?
Yes, sir.
Yes, sir.
Okay,
We can see.
you can even solve this question with eyes. The reason why now I've focused so much on these electricity questions, we are going to solve them this year in a month from now. So don't make mistakes. You're going to solve these questions, right? So calculate the current through the battery, even without going anywhere. Number one, you can screenshot this question and we start solving together. Don't forget to be screenshotting all the questions. The solutions, you have them because we are solving them. So you screenshot this question, then we'll start solving them together now. Okay, make sure you have it in your phone as we start solving. So analyze the question first. You have the voltage, 4 volts, you have the resistance, and you know that it is in series. To find the total resistors in series, you add them. So what is the total resistance here without going anywhere? 4. You've seen, right? So even without bringing on screen, EV Daramaning is simple. This one is simple. You say resistance, okay, is equals to, you add 3 ohms plus 1 ohm, meaning the total resistance is equals to 4 ohms. That's how you find the first one. Okay, so the answer for the first one, it is 4 ohms, but the question is asking you to find the current. So you are just finding resistance as a reference to what you're about to start solving. So you're just finding resistance as a reference to what you're about to start solving, because you know to find this, let me bring a different color here, put red. Okay. To find the current through the cell, to find the current through the cell, what happens is resistance is equals to voltage over current, like this. So this means that you need to have the total resistance, where total resistance, you simply add 3 ohms plus 1 ohm here. Your total is going to be 4 ohms. You get your total resistance by adding, because they're in series. You put it here. Our 4 ohm resistor is equals to, what is the voltage? The voltage is 4, which is the total here, 4 volts. Then what's the current you do not have? You cross multiply here, meaning 4I is equals to 4. You divide this side over 4, even this side over 4, meaning the current at this point, it is equals to what? 1 amp. That's how you find your first answer there. Good. And it was just 2 marks. Imagine, 2 marks for Mahara. That's how you find your answer there, right? So after finding your current as 2 amps there, the next question, what it's asking you is how long? How long means time. So how long could it take a charge of 2 coulombs to flow through the battery? That's the question, how long? So you're going to use the formula for current is equals to charge Q over time. Charge is represented by Q over time. As I sent you those tutorial videos, I explained this. Okay. So meaning what's the current that we found? The current we found it was 1 amp at first. So we're going to say our current was 1 amp is equals to, what is the charge? Charge given in the question was 2 coulombs. So 2, what was the time? We don't have the time. So we cross multiply here. Are you seeing that? Meaning our time is going to be 1 times 2, you have got 2 seconds. So meaning the time is 2 seconds. Is it clear on this one? Is it clear? Before we proceed, this is a simplest.
Kindly
Okay.
repeat,
Okay.
sir.
What's your name?
Victor.
This one. Okay. Okay. So you can screenshot the question. So the question is simply because we have something like this here, and this is 4 volts, and here we have 3, and at this point we have 1 ohm, 3 ohms, and the first question is saying find the current. So to find the current, we use resistance is equals to voltage over current. So the total voltage, or you can write your data like this. What's your total voltage? Your total voltage is 4 volts. What's your total resistance? You don't know, but you can simply find they're in series, so you have to add. Total resistance in series is equals to 3 ohms plus 1 ohm, meaning total resistance is 4 ohms, meaning what is our resistance? 4 ohms. What is our current? Our current we do not have, question mark. Therefore, we substitute what we have here. This is 4 ohms is equals to voltage is 4 volts, and the current is the one we're looking for. At this point, you cross multiply, meaning it's 4 current is equals to, we have 4 here. You divide over 4, even this side over 4, meaning our current is equals to 1 amp, like this. So we're done finding the current first. Question 2 was asking you to find how long we will take a charge which has got 2 coulombs. So the formula for current is this: current when you have charge is equals to charge over time, right? So the question, other data, the current we found it's 1, and the charge given, the question said it was 2.0 coulombs. So we are going to substitute what we have. What is the current? The current we found it was 1 amp is equals to, what is the charge? The question gave us the charge as 2.0 coulombs. Then they're asking you to find the time. At this point, you cross multiply. So 1 times t, here you have got 1t is simply t over which is the time. 1 times 2.0, you get 2.0 seconds. 2.0 seconds, like this. This is how you find it. Is it clear now?
Yes, sir. Thank you.
Okay. Now, the next question, it is similar. It was asking you to say how much energy could be used in the moving the charge around the circuit. So to find energy, this is the next tutorial video that I'm supposed to give you, online students. The tutorial video on how to find energy. So energy is found by voltage times current times time, formula number 1. Formula number 2, energy is found by power times time. Formula number 3, power is equals to voltage times current. So see what they do here. Power is equals to voltage times current. So if per energy you already have voltage times current, it means it is representing what? Power. So you can use any of these formulas to find the power or the energy. The question was asking us to find, what was the question saying? How much energy? So according to the data that we have, we're going to write everything that we have according to the data. So our data is like this. The current, we found it was 1 amp. The voltage, according to the question given, the voltage was 4 volts, right? The time, it was the one that we found, 2 seconds. So we use the formula of energy is equals to VIT, voltage times current times time. Meaning, what's the voltage here? The voltage is 4 volts times what's the current? The current is 1 amp times what's the time? With the time we found it was 2 seconds. So you put 2 seconds here. Meaning our energy is equals to 4 times 1 times 2. Your answer is 80 joules. Meaning 8 joules is the correct answer for that question. And that's how you do it. We proceed to another question if there is no question from you. Okay. This is question 1. Can you see this question? Screenshot. Tell me if you're done. This is not the question Kosovo. Tell me if you're done. Okay. Let's proceed. Karimak. Who can solve this one? I want someone to read. Someone to read it. Someone to read the.
Okay, so let
I'm
me
checking
read.
it on YouTube.
Let me read.
I'm sure it's showing on YouTube. Yeah.
I read.
Okay. So yes, you can.
Okay, so it says.
So you
the
can
figure,
zoom it.
Says the figure below shows a circuit diagram consisting of a battery of EMF 48 volts connected to 4 resistors. I go on.
Yeah, proceed.
What is the effective resistance of the 3 ohms and 6 ohms resistor? That's A. B, it says, what is the reading of the ammeter when the switch is closed? C. Calculate the energy displaced by the 3 ohms resistor in 2 seconds. D. What is the power of the battery?
The power of the battery. Nice question. So hope you've all screenshotted that question. Screenshot, removing it now. We solve. Okay, this question is not that bad. It requires you to think, but it has already directed you what to do. So the question is saying, what is the effective resistance of the 3 ohms and the 6 ohms resistor? They mean it is now in parallel. So you say total resistance in parallel is equals to resistance 1 times resistance 2 over resistance 1 plus resistance 2. That's what you do. So you look at the values given, 3 times 6 over 3 plus 6. So 3 times 6, what do you find here? Simple answer. What do you find? You have 18, right? This is 18. Then 3 plus 6, you have 9. So meaning your total resistance is giving you what? 2 ohms. You're done. And how many marks have you been given? Just 2. And you're answering these questions this year. So that's 2 marks. The next question is asking you to say, I'm sure you can see, what is the reading of the ammeter when the switch is closed? Now, when they close the switch, they now mean what is the entire current. So current moving at this point, and the one for the total that you have found. So the one that you have found, this one in total, it has made the 3 currents, 1, 2, 3, to be in what? In series. So you're simply going to add all these currents to find, all these resistance to find the total resistance. So these, and the one that you're going to find, they're going to be in series. They're going to be like this. This current here, the resistance at this point, and the one that you're from finding, which is 2. And at this point you have 4. And at this point you have got 2. So you add them. 2 plus 4 plus 2, you have 80 ohms as your total resistance. You can simply find the current now. So this is just the language of electricity. So resistance is equals to voltage over current. So what is the total resistance? After adding them, this, and the one that you're from finding the total, 8 ohms is equals to what is the total voltage? 48. The total voltage given is 48. Okay, 48 volts. Then you want to find the current through the cell. You cross multiply, meaning 8, okay, current is equals to, well, 48 here over 8, even this side over 8, meaning the current is equals to, you get your calculator, you say 48 divided by 8. Your answer is what? 6. Your answer is 6. Your answer is 6 amps. Simple. Is it clear how you find 6? Okay, it's clear. Yes, simple. You've seen, right? If it's not clear, I repeat. If it's clear, I'm quiet, it's clear. Okay. Safunsa Anadiapula. Next question. So we're done finding the reading of the ammeter. We found it's what? 6 amps. Calculate the energy displaced by the, you have been directed what to do, displaced by the 3 ohms resistor in 2 seconds. So energy is equals to voltage times current times time. But they are saying that displaced by the 3 ohm resistor. Why is the 3 ohm here at this point? 3 ohm resistor. So the 3 ohm resistor, meaning what voltage is at this point? So what voltage is passing at this point? Because the current is the same. So the current that you have found, it's going to be the same. Apparently, you have to think this one, anyone who is going to get it correct, you are now understanding this. So if you are solving on your own and you get this one, okay. So who wants to attempt? What should we do at this point? Because we need to find the current that is passing through Pali 3 ohms up. What current is there? Okay, then the voltage has already been given. But what current is passing through at that point? What current is passing through at that point? Can you see? Why is it blurry, board? Okay. Can you see? Let's be quick. I want to close. Been teaching since morning. So this is in series. This is in parallel. So in series, the current is the same, meaning at this point there's 6 amps. At this point, there's also 6 amps. But in parallel, we said the current is different. So how do you find the current? You say resistance is equals to voltage over current. What is the resistance? They have given you at 3 ohms. So you're going to say 3 ohms resistor. The voltage in parallel is the same, 48 volts over. What is the current? We don't know the current that is passing through at this point. You cross multiply, meaning 3I is equals to 48 over 3, even this side over 3. Meaning the current passing through at this point is what? If I'm not mistaken. The current passing through at this point is what? 48 divided by 3. What do you find? You find 16, right? So meaning the current is 16 amps passing at this point. At this point, there is 16 current passing at this point. Okay. Are you all here? So now the current that you have found passing through at that point, how do you find the total now? How do you find the total? So the question was given like this. Why is my question? This is the question. You've seen. So the current at this point is the same, right? The current at this point is the same. Then what was our total current that we found? Let's redo the question. What was our total current that we found? And what do we do? So at first, what was the current? Is it 6 that we found? Let's talk. What was the current that we found at first? We don't want to resolve the... It was what?
6 amps.
So 6, right? Okay. So the current that we found at first, yes, was 6 amps. But now, according to this question, let me draw it like this. This is your question. And the question is now saying that you have 3 here, and you have another one, 6 at this point. It is so. Here you have 48 volts. Okay. Now, 4 ohms, 2 ohms, 3 ohms, and 6 ohms. The key guidance is this. If the total at this point, if the total was 6 amps, the rule of electricity is that in series connection, the current is the same, meaning up Papa Peter 6, na Papa Peter 6. But what current is passing through at this point? The current has to be different at this point, and at this point has to be different, so that when you find that total current, it's supposed to give you the current that is there, which is 6. Okay. So my question is, if we want to find the energy, the question is find the energy displaced by the 3 ohm resistor in 2 seconds. So they want you to focus on this part now in 2 seconds. So how do you find the current passing through at this point? That was my question now. How do you find the current passing through at that point? So you have 1, 2, and the whole of these 3. So how do you find the current passing through at this point? That's my simple question before we proceed. Because you have to understand it properly, then we proceed to what the question is asking you. So voltage we have is 48, but how do we find the current now? How do you find the current? Quick. The time has been given saying the time is 2. The time is 2. So what do we do with the voltage? Let's talk. So if you're focusing at this point, let's share the voltage. Simple things. Let's share the voltage. This is in series. The voltage is different. This is in parallel. The voltage is the same. So what voltage is going to be at this point and what voltage is going to be at this point? This is what we have been learning. So you can find what voltage is at this point and voltage at this point. The ones that remains is going to be the shared voltage for everything here. The shared voltage for everything here. So what voltage is at 2? You do this. Resistance is equals to voltage over current. Okay, the resistance is 2. The voltage, we don't know the voltage passing through at this point. We're at the PD. What is the current? The current, we're saying it is the same in series 6. So meaning our voltage V is equals to this times this, we get what? 12 volts. Meaning at this point, we have got 12 volts. Are you getting that? At this point, we have got 12 volts. What about at 4? How many volts do we have? Resistance is equals to voltage over current. So this gives us the resistance of 4. What is the voltage? You say the voltage. We don't know the voltage passing at this point. What's the current? The current is the same. So you cross multiply, meaning our voltage is equals to, you get your calculator. You say, okay, now I have 6 times 4. What do you find? You find 24 volts. So, meaning at this point you have 12 volts, at this point you have 24 volts. And this is now in series connection. How many volts are remaining for it to be 48? So you're going to say 12 plus 24. This is giving you what? 36. 36 minus 48. What's the answer? 12. Meaning this is the voltage that you remove in what? In series. You remain with the shared voltage because in parallel, the voltage is the same. So what you say is the voltage remaining is 12 volts. Because when you add 12 plus 24, you get what? You get 38, is it? So 12 plus 24, you get 36, So 36 is the one in series minus the total, which is 48, you get 12 volts. So 12 volts is the one that remains in parallel. The voltage is the same, meaning up 12 volts, Peter, now Peter 12 volts. Then you can go ahead now and find your answer by saying what current is passing through Pali 3. So resistance is equals to voltage over current. What is the resistance? 3 ohms. Then what is the voltage? The voltage we have found in parallel, the voltage which is shared is what? 12 volts. What's the current? Because the answer for all this is supposed to give us 96 watts, we'll see. So this times this is giving us 3I, and we have 12 here. So you divide over 3, even this side over 3. Meaning what is the current passing through Pali Upper? The current is 4 amps. So we have now energy. Energy is equals to voltage times current times time. What is the voltage at this point? 4 volts. Times what is the current at this point? The one we're from finding 4. Times what is the time at this point? The question said in 2 seconds, right? The question said in, where is the question? The question said in 2 seconds here. So we have 2. So meaning energy is equals to, you get your calculator, you say 12 times 4 times 2. Your answer is 96 joules. That's how you find your energy. So these electricity questions, they just require you to understand them, and you see you are going to become very sharp. And the last question is saying, what is the power of the battery? How do you find power? Power of the battery. There are a lot of questions, there are formulas that I've given you to find power. I've said the other one is power is equals to voltage times current. Power is equals to voltage times current. So what's the voltage? They have said of the battery, meaning the voltage you get total of the battery times what's the current? The total current of the battery that we found is 6. When they say of the battery, they mean the total. So 48 times 6, you get 2 88 watts, capital W, like this. Good. You've seen how you solve these questions? You can't just be perfect, but you have to be attempting them. So the last question for tonight is this one. Last question for tonight is this one. Screenshot, can you see it? Some you did it in class, but let's see the last one before you go. So online classes for online students, we're starting our lessons on Monday. We have cost of electricity, we have transformers, we have generators to do extraction of metals. Yeah. So screenshot this question, and this is very simple now. Calculate the effective resistance of the two resistors here. So to calculate the total resistance, simple, you just use the formula, right? What formula do you use? I'm removing it. Okay, so what values do we have? Total resistance, someone told me at per screen. Resistance 1 times resistance 2 over resistance 1 plus resistance 2. What is resistance 1? A good question. Okay, found it. So this is the question 4 and 12. So resistance 1 is 4 times 12 over resistance 2, 4 plus 12. So this gives you the total where you say, okay, you have 4 times 12, you get your answer 48 over, you have this one, which is 16, is it? So you have 16. So what's the total? 48 divided by 16. What's your answer here? 3 ohms. You're done. That's your answer for the first one. Then the second question is requesting you to calculate the value of the current in 4 ohm, because in parallel, the current is different. So what current is passing through this point? You're going to say resistance is equals to voltage over current. What resistance have you been given? 4 ohm resistor. So 4 ohm resistor is equals to what voltage? In parallel, the voltage is the same, but current is different. So it's going to be the same 6 volts. What current at this point? You don't know. You cross multiply. 4 current is equals to 6. You divide over 4, even this side over 4. Meaning the current is equals to, you get your answer as 1.46 divided by 4, which is 1.5 amps, like this. This is how you find your current. Okay. Then the next one is saying you can find the current of the battery. So you go straight, current of the battery. You use this formula. Okay. Total resistance is equals to total voltage over total current. Total resistance, the one you found, 3 ohms. What was the total voltage? 6. Total voltage was what? 6 volts. Then what's the current? We don't know. We cross multiply here, is it? The question is saying the current of the battery, the full current now. So the resistance, the total. Did we find the total for the resistance? Yes, 3. Did we find the total voltage of the battery? Yes, 6. So what you do here, 3I is equals to 6 over 3 over 3. So current is equals to 2 amps. That's the total current. Okay. And the last question, could the addition of an extra resistor between point A and B in parallel with the original resistor increase or decrease the current? So always when you increase the resistance, the current increases. Always put it in mind. When you increase the resistance, always the current increases. So the answer is say it would increase. This is because the more resistors you have, the more current is going to be obtained. So you increase the resistors, the current is going to increase there. All right. So, and this is the end of our session. This is the end of the class. We're done 1 hour. 10 minutes. So if you have any questions, you can ask. Our class is done. The next class will be for something else. I already have past papers here. So for past papers, I just bring them at this point and where we're just flipping, answering them together like this. I have my pen, then we start solving them together, just like that here, if we're having those kind of live classes. So don't worry for that. If we do not have any questions, we say bye-bye. See you in the other class.